Yes, hi everyone. Good evening. We're back. And as I have discussed that, in fact, I have informed that I will be talking about very new topics not taught anywhere. The huge possibility that once upon a time in GATE exam, IIT Bangalore has also asked how many number of factors, how to calculate. I'm not talking about linearly independent, about linear eigen vectors, right? There are two concepts. One is linearly independent vectors and one is linearly independent eigenvectors. This session I will be talking about linearly independent eigenvectors, not vectors. I will discuss separate session once I will start vector space. This session, the topic we discuss like multiple. Third topic will be number of There are three topics that are completely new. What is the meaning of algebraic multiplicity that we have to understand? So I hope my voice and everything is perfect. Also, my voice is audible to everyone. Like this, yeah. You can write also in the chat box whether my voice is audible or not, right? So that I. Uh, okay, perfect. So in this session, let us begin. What is the meaning of algebraic multiplicity? See, why I'm talking about these two concepts? Because these two concepts will help you determine number of linearly independent. You will also study about linearly independent vectors. Linearly, but not in this season. It's a different topic, and this is the different topic. Linearly eigenvector. Because I have already explained you what is the meaning of vector as well as the eigenvector. There is a huge difference. I have taken two examples, two vectors we have taken. Then we have got the and okay, perfect. My voice and everything start about algebra. Everything is only. It is not fine, then we can take. So let's begin here. So what is the meaning of algebraic multiplicity that we have like? So already we have talked about what is the meaning of eigen value, right? If you know the meaning of eigen value, now you can talk about algebraic multiplicity. What is the meaning of algebraic multiplicity? Whenever you get the roots of the characteristic, the meaning of algebraic multiplicity is what? Multiplicity of eigen value. Multi of eigen value, or sometimes we call it root eigenvalue as a root of what? Root of characteristic. What is the meaning of multiplicity? What is the meaning of multiplicity? Can somebody tell me multiplicity? Repetition. Okay. If number of suppose you have got the eigenvalue 2, right? How many times 2 is being repeated? That is the meaning of multiplicity. Suppose I take one pole at origin, three poles at origin. There are three. What will be the multiplicity? Multiplicity. In this case, we have to discuss algebraic multiplicity with respect to eigenvalue or the roots of the characteristic. So this is what is the meaning of multiplicity? How many times the eigenvalue is getting repeated? How many times the eigenvalue eigenvalue is getting repeated? Suppose I take here. Just I'm taking one example here. So the basic definition, number of times. Basic definition is what? Number of times lambda. Lambda is what? Eigenvalue is repeated. That is the meaning of algebraic multiplicity, or we call it AM, or we call it AM. Please keep in mind how many times the eigenvalue gets repeated. So I'm just going to give you the example. Suppose we have got lambda is given as 3 and 5. There are four eigenvalues. Okay, we have got four eigenvalues. Okay, so what will be the somebody will ask you what is the multiplicity of of 3? Can somebody tell me what is the multiplicity of AM of 3? So how many times 3 is getting repeated? That is 2. So you can find the algebraic multiplicity of eigenvalue. How can you find algebraic multiplicity of eigenvalue? Just see that how many times it is getting repeated. So here there are two threes, right? You can say algebraic multiplicity is gonna be what? Algebraic multiplicity is gonna be 2. If somebody will ask you what is the algebraic multiplicity of 4, so it will be 1. Somebody will ask algebraic multiplicity of 5, that is 1, right? No harm is there. I think this is clear. Okay, I hope this makes sense. So what is the meaning of algebraic multiplicity? The basic definition I'm telling you is number of times the lambda gets repeated. Okay, so suppose you have got three eigenvalues. They are not distinct. Okay, two eigenvalues are same, one eigenvalue is different. If all eigenvalues are different, suppose all eigenvalues are different, suppose if all eigen are distinct, then algebraic multiplicity what? Algebraic multiplicity for lambda will be 1. That you have to keep. If two eigenvalues are getting repeated, right? So you have to say 2. Algebraic multiplicity 2. That always keep very important. Okay. So this is one concept. You can take one example here, right? So and now we will talk about geometric multiplicity. Geometric, and then we will solve some of the problems. Geometric is very important concept. This year in 2024, in coming year, question can be asked. If you don't know the concept of GM and AM, then it will be very difficult to calculate the number of linearly independent eigenvectors. Linearly independent eigenvectors, correct? Geometric multiplicity means here it is like geometric multiplicity. Okay, so what will be geometric multiplicity, that we have to understand. The basic definition I will just tell you what is the meaning of geometric multiplicity. Geometric multiplicity is nothing but the number of linearly independent eigen right here is number of linearly independent eigenvectors corresponding to an eigenvalue. Okay, that is what the definition of geometric multiplicity. Number of linearly independent eigenvectors corresponding to an eigenvalue. Right? that you have to keep in mind, these two definitions. Okay, now the question is how to compute AM, how to compute GM. So I have told you calculation of AM is straightforward. Calculation of AM is what? Straightforward. You guys can calculate the algebraic multiplicity, but calculation of geometric multiplicity needs some caution, right? You need to be careful while calculating the so in the question what they will give you the matrix, and you have to find the number of linearly independent eigenvectors corresponding to an eigenvalue, that is geometric multiplicity. So I'm just taking some example here. That example you have to keep. Okay, suppose we have got m of eigenvalue is equal to corresponding GM will be also 1 in this. Corresponding GM will be also 1 in this. Keep in mind this very important concept. Okay, if remember, if if algebraic multiplicity is 1, okay, so corresponding geometric multiplicity will be always 1. This is very important concept. Now if eigenvalue is getting repeated, then your AM will be updated also, right? Your AM will be what? 2. Suppose your AM, okay, algebraic multiplicity of the eigenvalue, some eigenvalue is 2, then GM will be always, your GM will be, GM means geometric multiplicity of that lambda. Okay, that lambda will be always less than or equal to 2, cannot be greater than 2. Remember, this is very important concept. Okay, this is very important concept. If AM of eigenvalue, algebraic multiplication, okay, multiplicity, sorry, of the eigenvalue is 2. What is the meaning of 2? There is a eigenvalue which are not distinct. Okay, not all the eigenvalues are distinct. There are 2 eigenvalues which are getting repeated. So these are the basic concepts that you have to keep in mind. I believe this is fine. So AM, if AM of eigenvalue is 2, then your GM of eigenvalue will be always less than or equal to 2. Okay, and what is GM? GM is basically the number of linearly independent eigenvectors. Number of linearly independent eigenvectors that you have to keep. So from this what we can conclude, your AM will be always greater than GM. But your GM of lambda will be always less than or equal to AM of lambda. This quality you have to keep, very very important, because in the exam they might ask that AM, which one is greater, right? So AM is always greater than GM, or it can be equal also, right? Suppose we have got AM of eigenvalue 5. What will be the value of GM? So you have to write always like this: GM of lambda be always less than or equal to 5. Very important concept. You can find, you will never find these kind of concept on any YouTube channel across India. Any, no matter how popular that face is, that I can make sure. And if you understand this concept, then finding the number of linearly independent eigenvector will be very easy for you. That you have to keep. I hope this makes sense. So how to find geometric multiplicity? That you have to see. You can find algebraic multiplicity directly. Here I am just writing calculation AM of lambda I, straightforward. But how to calculate AM of lambda I? Lambda I means there are different lambdas. I mean there are many lambdas. I can be 1, 2, 3. Okay. So how to calculate GM of lambda I? That is the big question, right? So I'm just giving you the very easy way of calculating this. Very simple way of calculating this. What you have to do here is always GM of lambda I will be n minus r. What? N minus r. This r is not corresponding to, remember, this r is not corresponding to rank of the matrix A. No, this R is corresponding to rank of A minus lambda I, rank of A minus lambda. Okay, always you, whenever A is given, okay, whenever A is given, you have to compute A minus lambda I, then find out the rank of A minus lambda I. I hope this makes sense. Okay, this kind of a definition you might have seen while calculating the limit, while calculating the free variable, okay, number of free variable in the matrix. Okay, while solving the system of linear equation, we can find the free variable. Okay, but in this case, this R is meaning, what is the meaning of this R? R is basically the rank of A minus lambda I. Okay, okay, or you can say number of pivots in A minus lambda I, not in A. That caution you have to keep in mind, right? And what is n? N is the number of unknown, right? N is what? Number of unknown. This is very simple now. Anybody can find. Okay, so lambda, gm lambda I. Okay, gm of lambda I means geometric multiplicity of lambda I. Okay, so in this manner you can calculate the number of linearly independent eigenvector. Number of linearly independent eigenvector. So in ISC Bangalore, when ISC Bangalore conducted in GATE 2016, okay, 2016, they have asked questions. This year also we can expect, upcoming year, number of linearly independent eigenvectors. So please keep in mind, guys, gm of lambda I, how can we find? Suppose we have got lambda 1, so we want to find geometric multiplicity of lambda 1. So what we have to do? N minus R. So we have to first of all calculate A minus lambda I. For that lambda, we have to calculate A minus lambda I. How to calculate A minus lambda I? That you know. We have to just subtract lambda 1 from the diagonal. Then we will be able to see the rank. How can we find the rank? We have to apply elimination. That these kind of shortcuts are, everybody knows that. Okay, not to explain again and again. So we will take some questions, you will understand. So let me take one example. And just you have to evaluate. What? You have to just evaluate the AM first. Example number 1. Suppose we have got the example. Simple. What will be given? Simple eigen matrix will be given in the question. This is a matrix given. 2 this is the matrix given, and they are trying to find out, they are asking that what will be the algebraic multiplicity that you have to determine. So suppose we have got the characteristic equation, have to just find the det of A minus lambda I. So find out the lambdas, right? You will find lambda here. Lambda will be, after solving this, get lambda as 2. You guys can try how to find the eigenvalue from this. So you have to find lambda, then you can find am of 2. Am of 2 will be what? 2, because 2 is getting repeated 2 times, and you have to find am of 8. That will be, am of 8 is 1. Here we have got the algebraic multiplicity directly. So I hope this makes sense. Now the question is how to find eigenvalue. You should know, because I have discussed in detail. Chalo. Next is next example I will take, just so that we can also calculate the number of linearly independent eigenvectors, right? So suppose we have got a question here, and the matrix M is given, right? Matrix M is given as 3, 4, 5, 0, 6, 7, 0, 8. In this question, you don't have to worry about how to compute eigenvalue. Can somebody tell me what will be the eigenvalue here? You see, this is a special matrix. Okay, this is a special matrix which is known as upper triangular matrix. Okay, so one of the properties there, if upper triangular matrix or lower triangular matrix or diagonal matrix or scalar matrix or identity matrix are given. So you can directly find out the eigenvalue. You don't have to solve the characteristic equation to determine the roots of the characteristic, right? You can directly, you can say that here the eigenvalue will be 2, 3, 8, 3, 6 and 8. I hope this makes sense. Okay, so you can see here guys, all guys are same. Okay, not sorry, all eigenvalues are distinct. Okay, here all eigenvalues are distinct. So we can find out the am first. Am of 3 will be 1. What will be gm then? Gm of 3 will be also 1, corresponding. Okay, as I told you in the beginning only, right? If am of some eigenvalue is 1, so gm will always be 1. That you have to make sure. Now am of 6 is 1. So what will be gm of 6? Gm of 6 is 1 only, right? This is very easy question, you can say. And in this case, what you have to find out is find out number of number of independent eigenvectors, not simple vector. Okay, eigenvector. So this kind of question will be asked. Okay, they will give you the matrix and you have to find the number of linearly independent eigenvectors. So how can you find? See, am of 3, algebraic multiplicity of 3 is 1, gm of that is 1 always, right? If 6 has am 1, so gm of 6 will be 1 always, right? If am of 8 1, what is the value of gm? Gm of 8 will be 1. I hope this makes sense. You guys can watch this session any number of times later as well. So because the first go you might not be able to digest because this is completely new, but you should know because nobody teaches in college as well as level as now. So this is the fact. Now if somebody will ask you what is number of linearly independent eigenvector, linearly independent eigenvectors vectors 2, the relation between gm and it will be gm of 3 okay, this is going to be 1 1. What is the answer here? Answer will be 3. Okay, so if somebody will ask what is the answer, so answer is going to be 3. Okay, so what is the relation between linearly independent eigenvectors and the gm, geometric multiplicity? That is sum of all geometric multiplicity of lambda I. So remember this is very important. Okay, number of Li linearly independent eigenvectors equal to sum of the 1, sum of lambda 1 and so on. This is the very important definition that you have. I believe this is fine for everyone. Okay, so if eigenvalues are different, okay, distinct, all eigenvalues are distinct, so their am will be 1 and the corresponding gm will be 1 here, right? Okay, that you have to keep in mind. Let us see one question. It was asked by ISC Bangalore, mechanical engineer. I will solve that question. So you see here, we have to calculate everything. In this case, what is there? Eigenvalues are distinct. Okay, you will get number of linearly independent eigenvectors. Okay, with 3. How to compute number of linearly independent eigenvectors? Just by finding the gm of that lambdas, then sum them up. Okay, then sum them up. This is the basic relation. Sum of all gm the I going from 1 to is the number of linearly independent eigenvectors. Let me take one question. It was asked 8 and the year was No, 20 mechanical engineering. Check the year, but you can buy ISC Bangalore. Whenever ISC Bangalore conduct the gate examination, like is going to be conducting your gate 2024, they will be focusing on linear algebra. That is the reason I am giving lectures. So suppose we have got the eigen values here, right? We can take what is given here. They are asking find the question is find the number of fairly independent eigenvectors and vectors of given matrix A. A is given as this. Here 2 1 0 2 0 0 0 3. So I think anybody can directly write the number of eigen. Anybody can write the value of eigen values, right? Because it is what kind of matrix it is. The upper triangular matrix. You can directly write the eigen values. Okay, you don't have to calculate. Okay, don't worry in the exam that gate examination will be very difficult. Okay, they will ask very big equations. Okay, we always waste our time. Everybody knows that. Okay, we always waste our time. We always focus on how to find eigen values of 3 by 3 matrix. Don't worry, guys. In the gate examination, they will give you that kind of a matrix whose solution will be very easy. I mean, anybody can handle that. Okay, despite you don't know how to compute, how to solve cubic equation, because in the exam you don't have that much time to solve cubic equation. In this case, the eigen values are of A will be 2, 2, and 3. Okay. Now the magic is now you can tell what is the algebraic multiplicity of 3 first. So let me go to next page and try to solve this. We have got eigen values here, that is 2 and 2 and 3. What is the algebraic multiplicity of 3 first? 1. You can directly tell GM of 3 will be 1. Okay, life is very simple now. Okay, I think this is fine for everyone. Yeah. So because 3 is not getting repeated, so you can directly find AM and GM. No harm, no caution and all you have to do. But if you calculate AM of 2 will be what? It is 2 only, right? Because 2 is getting repeated 2 times. Now there is a caution. You can't, you see, after all your GM will be less than or equal to 2, right? GM can be 2 or it will be less than 2. GM can be 1 as well. But how? GM can be 1. Number of linearly independent vector will be how much? 2. But we have to calculate. It can be also 2. We don't know, right? So we can calculate GM of 2 by using n minus r formula, right? What is n? N is number of unknowns. So if there are 3 eigen, how many unknowns are there? You see, guys, unknowns means number of column. Okay, number of column means number of unknowns. Okay, that you have to keep. So there are 3 unknowns, right? You can use this. This will be 3 minus r. Now, what is the value of r? As I told you that r is nothing but rank of a minus 2i, right? A minus 2i, because here the lambda is 2. Okay, now can we compute a minus 2i? A is given as, what is a given in the question? Here I'm taking this. This is a, right? Now we can evaluate a minus lambda I from here. A minus 2i we have. A minus 2i will be what? Just subtract 2 from here. So it is 0, 1, it is 0, it is also 0, it is 0, it is 0, it is 1. Now can somebody tell me what is the rank of this matrix? What is the rank of this matrix? Sorry, I think only the problem, right? Perfect. Yeah, it is correct. Okay, it is correct. What is the rank of this 0 1 0 0 0 0 and 0 0 1, right? So rank of this will be directly, you can find out rank now. Okay, you don't have to reduce and all, right? So rank of this matrix, rank of A minus 2I be 2, because you can see here, if you take this guy up, right, you can interchange rows and all, right? Okay, because in swapping row, interchanging row does not affect rank. So in this case, what you can do? You see, guys, this will be the rank. So here you can say one pivot is there, one pivot is there, right? Two columns, there are pivots. See, you can say the rank of this matrix will be 2, right? Rank of this matrix 3 minus 3 minus 2. 3 minus 2 means what? The GM of 2 is 1, right? GM of 2 is 1. So now anybody can find out the number of linearly independent eigenvectors. Number of vectors will be 2, GM of plus GM of GM of 2 is 1, GM of 3 is also 1. Answer will be 2. I hope this makes sense. Yeah, I hope this makes sense. So remember this is very important concept. So if you don't know the concept, you can't solve this question. You cannot solve this question, right? So this was a question, very good question in fact, right? So I hope this makes sense for everyone. Eigenvalues and eigenvectors, how to find uh, number of linearly independent eigenvectors. Let me conclude here now. Keep in mind how to evaluate. Number one is AM. AM of lambda I, what? Number of times lambda I get. What is PM? PM of lambda I. PM of lambda I, but okay, but minus R. Minus R, where n is but number of what is R here? R is nothing but rank of A minus the I, rank of lambda I. So how to evaluate rank and all? You know, right? Number of pivots you can. So this is what I wanted to discuss. I will not elongate this session longer. Only 3 topics I wanted to cover. So I hope you guys might have learned concept how to find AM, how to find GM. I hope this makes sense. And one more question you have to remember is, suppose, note here, AM of any lambda, suppose lambda 1 is 1, your GM will be always 1. GM will be always 1. If AM of lambda 1, 2, suppose lambda 1, 2 times lambda 1 is getting repeated. AM is nothing but 2 times. So, and why we call geometric multiplicity? That is also another very important. See how we do vector interpretation. Since beginning only, when I started linear algebra, I have been emphasizing on geometrical interpretation of linear algebra, right? That was the vector interpretation. Okay, so AM of lambda 1 is this, then GM will be what? GM can be less than or equal to 2. Don't take exactly 2 or less. Okay, first of all, you have to calculate. Don't blindly say, okay, answer will be this. You have to evaluate the rank of the matrix. Rank of which matrix? Rank of A minus lambda I matrix. Okay, so its rank will always be less than the number of unknown. Why? Tell me why. See here, the rank of this A minus lambda I will be always less than the number of unknown. Why? Because A minus lambda I is what? What kind of matrix is that? A minus lambda I is the singular matrix. This is basically the singular matrix. The matrix is singular. Okay? The rank of the matrix will be always less than what? Less than the order of the matrix. That you have to keep in mind. I will discuss rank as well in one of the sessions. So I hope you guys might have understood. You guys can watch this any number of times. Let me know how was this session, whether you know this concept or not. Okay, we'll meet in the next session. uh, the next session topic, what are the topic we have got? Is still the heart of linear algebra. The heart of linear algebra is, but first is vector space, the concept of vector space. Second is the concept of subspace. Third is concept of concept of uh, uh, linear span. Fourth is concept of spanning set. And concept of linearly independent vectors. Dependent vectors. Linearly dependent vectors. Both are different. Something is independent. If something is not independent, means you can say. So I'm not talking about linearly independent eigenvectors. I will be talking about linearly independent vectors, right? How to find whether given vectors are linearly independent vectors. So I will be giving you systematic approach. Seventh topic will be what? In fact, this concept will be discussed in the next session, right? So linearly independent vectors. So you know, in ISC Bangalore this time, one of my colleague, went for the interview. So he was asked this question: what is the meaning of linearly independent vectors? Many people don't know. Just they know matrix and determinant, finding inverse of the matrix, finding adjoint of the matrix. ऐसा कर लो, ऐसा कर दो. I know how people study linear algebra. Linearly independent, linear dependent. Okay. Now, if you know the concept of spanning set as well as the concept of linearly independent vectors, so we'll discuss the concept of basis. Ninth is the dimension. These are the important concepts, and in this we will discuss very important topic, that is called as linear combination. Bunch of vectors. Already we have discussed that. Okay, these are the topic. Dimension is nothing but the number. Dimension is nothing but what the number is. Basis is nothing but the collection of what? What is basis? Basically, just I am going to show you the basis. What is basis? See, suppose this set belongs to the spanning set. This set belongs to a spanning set, and this set belongs to linearly independent. Here Li vectors are there. Here spanning set vectors are there. Okay, those vectors which are which spans the space. Okay, so what will be the basis then? What will be the basis? The basis will be this. The basis is nothing but not only the linearly independent vector, it should also be the spanning set, the combination, okay, intersection of linearly independent vectors as well as the spanning set. Now we have to understand what is the meaning of spanning set. Okay, we'll discuss these things. Spanning is nothing but generating sets. So if any vector is given and you have got other vectors also, so can we generate that vector with the help of other vectors. Okay, that's the meaning of span. We'll see spanning, systematic approach. Okay, so we have to learn the systematic of finding, systematic way of understanding the concept, finding, or you can understand. Thank you so much, guys. We'll meet in the next session. We'll discuss these concepts. Okay, the art of linear algebra. I hope you might have enjoyed the session, and this is very important. Thank you so much. We'll meet in the next session. Take care and bye bye. And keep watching this session any number of times. Bye.